So induced enzymes, we're going to talk about liver-induced enzymes, but we're also going to talk about some other places where these enzymes are made. And so these enzymes are membrane-bound, so not cytosolic, and they're within the cell. And these are normally kind of on a daily basis, these are normally released into the serum. And when a cell is stressed, and a lot of things can cause the stress, it makes a lot more of them. And a classic one is something called alkaline phosphatase. So when the cell is stressed, it starts making a lot of alkaline phosphatase, which then, since you normally release alkaline phosphatase, ALP, into circulation, that's a normal thing that happens when you're stressed, when your cell is stressed, it actually makes more and so releases more. So these increases tend to take a little bit longer to manifest than what we see in leakage enzymes, and that's because of increased production. So that's kind of an important thing to realize. So now let's talk about the different types and the animals that we see it in and kind of the cells that it comes from. So alkaline phosphatase, or ALP, has several forms that are called isoenzymes or isoforms that increase due to a variety of reasons. And the three forms, one is liver, and we usually abbreviate this ALPL. Another one is bone, and we abbreviate this one, I bet you guessed it, ALP bone. And the last one is something that we see in dogs only, and it's due to corticosteroids. It's also made by the liver, but it's because of corticosteroids, and so we call that ALK-Phos or ALPCS. The good news is that we really never differentiate these in terms of when we're doing blood work because it takes special testing. So we see them all together, but you have to know that different things increase. A few things to talk about is when we talk about ALK-Phos, we're mostly talking about dogs and cats. Sometimes you'll see it in large animals. It's just that it's not tremendously sensitive all the time, and so when we talk about it in class, we're only going to talk about it in dogs and cats. GGT is all species, and the primary place that it comes from is liver. How am I writing today? Primary place is liver, but also biliary epithelial cells, which are certainly associated with the liver. So GGT is also made by mammary epithelium, and so in some neonates, increases in GGT can be seen following colostrum ingestion. Just to mention it, we're not going to really go into that a lot. And the renal tubules make GGT, and so we can actually assess renal tubular injury with urine GGT levels, not serum, and that's all I'm really going to mention about that. So I made what I would say is an amazing page of enzyme increases lists by the various enzymes and the DAMN-V scheme, and that is in the notes, and I highly recommend kind of reviewing that. I may make a video covering it for those people who need me to say it aloud, but for now, if you were trying to figure out cases, I highly recommend visiting that page and being amazed by it. So there's a lot of causes of leakage enzyme abnormalities, and there's a little bit less with induced enzymes, and I'm going to kind of go through the common one. So remember a little bit ago, well, I remember it was a little bit ago for me, it depends on when you were watching the video, but if you have hepatocytes, right, so I'm going to make some hepatocytes here. Imagine it's kind of that slice of pie, and you have your portal vein, your hepatic artery, you have your portal vein, and you have your bile duct, right? And here's your central vein. So that's the kind of slice of pie that we were looking at before. And you have Kohli Stasis. So I told you that kind of looks black when I look at it on a slide, where, normally, let's say here's our bile canaliculi, and these were these areas that were our sinusoids. So normally the nasty products that would leave the liver and enter the bile canaliculus, but now something has blocked it. Let's say that you have some periportal fibrosis, which you can't see because I made it the wrong color. So we've got some periportal fibrosis, which is causing collapse of our bile canalicculus. Now what happens is this fills up, and that's called Kohli Stasis. That's intrahepatic Kohli Stasis. You can also have so here's your liver, right? So here's your whole liver. When it leaves through the common bile duct to go into the intestines, this area can be blocked, and that's extrahepatic Kohli Stasis. So both of those cause backup of bile within the liver. So that's what's to know. And so when Kohli Stasis happens, it does two things. One, it severely perturbs the liver and stresses it, and that induces production of alkaline phosphatase liver and GGT. And again, that's because of blocked bile canaliculi, and these surrounding hepatocytes get really frustrated because they do not like all of this bile being backed up. Other things happen, but we're going to leave that right there. So that would be Kohli Stasis causing that. The other thing that happens is the bile epithelial cells, so the actual cells of the bile ducts and the bile ductules become hyperplastic and secondary to Kohli Stasis, so we call that biliary hyperplasia, which can also form for other reasons. So that's more so GGT, but it can do the liver alk phos as well. So for now, we'll talk more about Kohli Stasis when we talk about bilirubin, because of course bilirubin's a waste product and it goes into the bile canaliculi. So if it's backed up, you're going to see bilirubin increase. And that's when we talk about the non-hemolysis causes of increases in bilirubin. One other thing that's sort of outside of all of this, of course, is your gallbladder, right? And so if your gallbladder is blocked, maybe there's a big colilith, a big stone, that's also Kohli Stasis, and so that can cause this as well. All right, so let's talk for a second about other types. So we said for liver, we have Kohli Stasis, causing increases in alk phos and increases in GGT. But again, alk phos has a couple other isoenzymes that we have to be considerate of, and one is bone. So when do we see this? Well, young growing dogs, and if you'll go back and look at the cases we did with hypercalcemia in those young growing dogs, you'll see that they often have an increased alkaline phosphatase. And if you did the special test to do it, you would see that it's alkaline phos bone, and it's secondary to osteoblast activity. And so that's what's making it in this case, is it's osteoblasts. Now, this is also true. You can see an increase in alk phos with osteosarcoma. That's what OSA stands for. And when you see the increase in alk phos, that can be a negative prognostic indicator, so not great. We also can see increases in alk phos with fracture repair, in case you had an animal that has a healing fracture. You want to kind of keep that in the back of your mind. Now, dogs on steroids, and this is again dogs only, they can be on steroids, have hyperadrenocorticism or really prolonged stress, and they can have increases in alkaline phosphatase, and these can be marked. And that is the corticosteroid isoenzyme, also made by the liver, but it's very specific to corticosteroids only in dogs. If you've got increases that are 4 and 5 times the upper reference range, we're going to think about Cushing's disease. Less, we're going to think about either normal stress potentially. Marked increases can also be seen when animals are given corticosteroids. So if you've given an animal any form of steroids, or a dog any form of steroids, you have to think about that when you look at liver enzymes. One other cool thing to mention about GGT in horses, they can get a displacement of their large colon, and it's a dorsal displacement. In fact, it's a right dorsal displacement of the large colon, and that can cause an increase in GGT. Obviously, you're not just going to use that to diagnose it, though. All right, next lecture is on bilirubin.